Welcome to Brain Vision.
Hello, hi. Once again, we have a new problem, and this time it's a model. It's a Bohr model, and it's an atom with a ground state electron. Okay, ground state electron. Looking at kinetic energy. So this is a hydrogen atom. So it's hydrogen atom, and the orbital speed happens to be 2,190 kilometers per second, which is the same as 2190 times 10 to the 3 meters per second. And also the mass of the electron happens to be 9.11 times 10 to the negative 31 kilograms. So the first part of the problem is to find the kinetic energy, which is given by 1/2 mv squared. We substitute those numbers. So the mass is 9.1 times 10 to the negative 31 kilograms. And then you multiply that by the velocity, which is 2190 times 10 to the 3 meters per second. So we're using the kinetic energy formula, which is the energy that the electron has while moving. And so if you plug in the numbers in your calculator, you get 2.18 times 10 to the 18 joules. And that's the kinetic energy of the electron. Okay, it's in orbital speed, meaning it's rotating. On the second page, we have the second part of the problem, part B, and this time we are gonna have a kind of like a different problem where you have a weight happens to be 1 kilogram, 1.0 kilograms, which is approximately 2 pounds, and you're dropping it to a height h, which is 1 meter. Okay, so we want to find the joules in kinetic energy it's going to have when it hits the ground. So this is the ground. Remember, there's an energy transformation going on from potential energy up until kinetic energy. By the law of conservation of energy, we'll say kinetic energy of the object equals to mgh. So this just means that all the energy, we don't have any losses. So this is the same as 1 kilogram times 9.8 meters per second squared times 1.0 meters. If you plug in those numbers, you get 9.8 joules. So this is the conversion. There's a conversion of potential energy to kinetic energy. And so on the ground, that's going to be the kinetic energy when it reaches the ground. In the third page, we have, let's just see this, 9.8 joules. So in the third page, we have, it's a question saying, is it reasonable for a child of mass 30 kilograms to run fast enough with a velocity, we don't know what the velocity is, and end up having a kinetic energy of 100 joules. So if the child is running, then their kinetic energy is 1/2 mv squared. We want to get their velocity, so we divide both sides by 1/2 m. And so we have v squared equals to this one. Algebra, when it comes up, when you divide by 1/2, it's the same as multiplying by 2. So 2k over m. And so v is plus minus radical 2k over m. We don't think about the negative velocity, so we'll just plug in the numbers. We have 200 joules. That's the kinetic energy. Times, or rather divide by 30 kilograms. And that's going to give us the velocity of the child. So assume someone is moving at 2.58 meters per second. The question is it viable for a child, a 30-kilogram child, to run that? I mean, they're light enough, so potentially they can. But being a child, it's going to be relative to whoever they are. People have different speeds, so you can have people of the same weight, 30 kilograms, running different speeds. But assume two 2.58 is about 2.5 meters. So that's a dash across the room, which is potentially possible. Hope you enjoyed the problem, and I hope you're having a good time. If you have any comments or question, just reach out. Okay, thanks. Bye.